Welcome back, everybody. So hopefully you have taken the exam at this point. If you haven't, please do so soon. The exam is due Friday. You have 3 attempts at it, so take it. If you're not happy with your score, take it again by studying up and now all that I've said a bunch of times. But now that we're going to be starting a new chapter, which is on like statistics. And if you want to talk about statistics, then we want to first off and start talking about averages. So to start off with, we're going to follow along to learn about the 3 different types of them, 3 different types of averages with a data set. And if you haven't seen this before, the curly braces mean a set of items, a collection of items. So the data set includes 15, 32, 15, 42, 100, and 27. Now, you see averages all the time in your daily life. There's a lot of averages being thrown at you. The average score on an exam, the average like the median household income, blah, 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 all those things being thrown at you left and right. And it can be the problem with statistics and averages in particular is that they can be misrepresenting of what's being talked about. So there are 3 main types. The first one is the mean. This is the average that we usually think of when we mean average. So to do it, you add up all the numbers. Add up all the numbers in the set. And divide by the total number of entries in the set. So add up all the numbers in the set and then divide by the total number. And that will give you the average. That's usually what we mean when we say average. And so this data set, it could be anything. Could be scores on an exam, though I would hope not. I mean, only one person got above a 42. So that wouldn't be a good thing, but they could be anything. We don't know. But so in this example, to calculate the average, to calculate the mean, which so we write mean is equal to, some people use the Greek letter mu to mean mean, but we'll just write mean. So we're just going to add up all these numbers: 15 plus 32 plus 15 plus 42 plus 10 plus 27, all divided by how many numbers do we have? We have
10 or 100.
Oh, thank you. Don't know why I wrote 100, 10 instead of 100. Good catch. So there are 1, 2, 3, 4, 5, 6. 6 numbers. And the good thing about the mean, in comparison to the median, which we'll talk about next, is that with the mean, you don't need to rearrange the numbers. So you can just add them there. And granted, with a lot of these problems, they ask you to find both the mean, the median, and the mode. So it would make sense to rearrange them. But the nice thing about the mean is you don't need to. And so you get 231 over 6, which is 38.5. So that's the mean. Now, there's an important note about the mean of a data set, is that the mean is heavily influenced by outliers. In the data sets. The mean is heavily influenced by outliers of the data set. That could be outliers on the left or right, smaller numbers or larger numbers. So for example, like just to give you an example here. Small one, but if you get a data set, you don't need to write this down, but 0, 0, and 100. Let's say these are the scores. Or 0, 0, and 5. Let's say these are scores on an exam, just for the sake of an argument. Like, there's only 3 people in this class, but whatever. Then, so 100 plus 5 plus 0 divided by 3 tells you that the average of the class would be a 35, when that's not really accurate. 2 people failed miserably, and the other person got 100%. So that 100 greatly skewed the data. It moved it up. So if you look at the average of the first 2 people, that's a 2.5 average. So it skewed the average up a full 32.5 points. So, and that's just with a small number like 0, 5, and 100. This is very, very common, and we'll do an example a little bit later. This is a very common tactic that businesses use to say that their average salary is so good, blah, 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 blah. Do you have a question? The mean is heavily influenced. Yeah, heavily. So companies will use this to really skew their amounts, because like their CEO will be paid like 32 times. Back in the day, it was like only 3 to 4 times, but regardless, they'll include that in the average salary, but then they'll use the mean instead of the median. And it'll say like, oh, the average salary here is really, really nice, when in fact it isn't. It's actually pretty low. It's just because that one person has such a large salary that it completely skews the data. So the median is the next one. And so we'll see an example of that in a second. The median is the second type of average. And the median is the quote unquote middle number of the data set so it's not just finding the middle number of a data set, because the data set isn't necessarily always organized from smallest to largest. So that's what you need to do first. So the middle number of the data set when the entries are lined up from smallest to largest. If there are 2, data values in the middle, we add them and divide by 2 to get the median. So if you end up having 2 numbers in the middle, which happens when you have an even number of data values, and we'll talk about this in just a moment. But if you have 2 in the middle, then you add them up and divide by 2 to get the average middle number. So the median, unlike the mean, is not heavily influenced by outliers, because they end up just being on the outskirts of the data set. And so the median is a much better indicator of things that really, really require, specifically when the data values are very, very widespread. So if you have that situation where it says the mean salary, you want to know the median salary. And that would be a much better indicator of what the actual salary of the company you're working for would be. So in the example, we need to first rearrange. So the data set was 15, 32, 15, 42, 127. And to rearrange that, we put, okay, looking at the numbers, the way I usually do this is systematic. So I just start, like, I look through the whole numbers to find the smallest number, and that would be 15. And then 15 again. So that gets those ones, and then 27. Then 32. Then 42. Then 100. That's the data set reorganized. And so the long method of finding the median number, the long way to do it, which is intuitive, but not very quick, is to just kind of go inwards. So that one and that one, then go inward one more. And so these are the two middle values. So two middle values implies that the median will equal 27 plus 32 divided by 2, which is 29.5.
So does that mean that there's always going to be an even number?
Not necessarily. So this was just one data set that I constructed. There are plenty more. There's infinitely more data sets that we can look at. And so that's where I'm going to show you the faster way. Because this is not too bad, but there's only 6 data values. We can just count inward because there's only 6. But what if there was a data set that had 100 values or 105 values or whatever? Do you really want to go, okay, 105 all the way down until you find the middle one? And so, quick way. To find median. Now, it's not quick per se at first, but once you learn the little trick. So if you have some number of data values, then if you divide that number by 2, you get the halfway point. So, so how do I want to write this? I've been thinking about how to write this for a long time, and I haven't found a nice way to do it. So step 1, divide the total number of data values by 2. Step 2, if the number you get is a whole number, so this is 2 parts. If you get a whole number, then, and I'm not liking the way I've written this at this point, but whatever, we'll write it in another way too. If the number you get is a whole number, then that number, let's call that whole number n. Whole number n. So like if you divide 6 by 2, you get 3. That's a whole number, so that's your n value. 3 is your n value. Then you have 2 middle values. And the median will come from the nth, and n plus 1th data value. The nth and n plus 1th. And so we can see that here. I'm going to do another example because this is very, very strange when we first see it, especially because I'm using a little bit more high math terms that we're not used to seeing, like using an arbitrary number n. But if you look at the top set, 6 numbers. 6 divided by 2 is 3. So the third entry and the fourth entry give us the average, just like we see up here. The third entry and the fourth entry. Average them and you get the median. So that's if you get if you get a whole number, which happens if you have an even number of data values, which makes sense. If you have an even number of data values, you can split it up right down the middle and there'd be the same number of it on each side. There wouldn't be a direct middle number. Whereas if the number you get is a decimal, n.5, since we're dividing by 2, it'll either be a whole number or it'll be a whole number 0.5. So if there's 7 values, divide that by 2, you get 3.5. If there's 9 values, you'll get 4.5. If there's 55 values, you'll get 27.5. So you'll always get an n.5 number. Then you only have one middle value. And the median will be the n plus 1th term. So let's see this in action. Let's do two examples to really understand how we do this. I know that looks very, very strange. So if you divide and you get a decimal number, you get like 12.5 or 15.5. So if you get 12.5, then the 13th number is your middle number. You get 77.5. The 78th number will be your median. You get 105.5. The 106th entry will be your middle data value. So let's look at an example of this. Now, I know like a lot of the data sets you'll see for your homework and for the exams and the quizzes and stuff will always be small enough that you could probably just go bam, 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 bam. But there's going to be something we see later called a frequency chart. And that will make it so that it's hard to do that unless you want to really write out 55 values. So example. Find the median of the following data sets. Where A will be the set 1, 4, 5, 5, 7, 10, 33, and 41. And the second one will be 101, 105, 117. You guys have a question? 118, 122, 137, 137 again, 149, and 150. And notice that I've already arranged these from smallest to largest, which is nice. But sometimes they're not that way, so we do need to rearrange them. So, and yes, this one isn't too bad to find the middle, but once again, if you have way more numbers, it will be a lot more of a tedious task. And I don't want you guys to be stuck doing tedious tasks if I don't have to do it. So counting the number of data values, 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 number of data values. 8. 8 data values. So 8 divided by 2 gives me 4. That means that's a whole number. So I'm going to draw a line. Whole number. So the 4th and 5th entries are used for the median. The 4th and the 5th entries are going to be used. Because we divided by 2 and we got 4, that means like we can see it right off the bat. There are 8 data values, which means there's an even number. So there should be 2 sets of the same amount of numbers, meaning that like there's no middle number. And so what you have to do is you find the 4th entry and the 5th entry. Because it was 4, 4th and 5th. If you got 7, it'd be the 7th and the 8th. If you got 107, it'd be the 107th and 108th. The number that you find, and then the next number in the sequence. So in this case, 1, 2, 3, 4, and 5. So the median will be 5 plus 7 divided by 2, which is 6. Any questions on that?
Why do we divide?
So I'm trying to find, so I know how, like, I'm counting how many data values there are. And if I divide it by 2, I'll find out what half the numbers would be. So if there's 10 numbers divided by 2, that means there's 5 at the beginning and 5 at the end. Is that all right? So that's why we're dividing by 2, since we're trying to find the middle point, the halfway point. With B, the number of data values is 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 divided by 2 is 4.5. That's a decimal number. So that means that the 5th entry is the median. So if you get 4.5, the median is the 5th entry. If you get 7.5, the 8th entry is the median. If you get 110.5, the 111th one will be the median. So the reason for that is if you're dividing by 2 and you get a decimal number, that means that your number is odd, meaning that there is 2 sets of equal numbers and 1 in the middle. And so we can see that, we can count that. 1, 2, 3, 4, 5. So the median is 122. Any questions on that? So that is the trick. Now, it's not wrong to do it the other way. You can just kind of systematically go through it. It's just, it's more time consuming. This is the way to save on time if you know the trick. Because when you divide by 2, there are only 2 options. You either get a whole number or you get a number 0.5. That's the fast way to calculate it. Any other questions? All right. And the last type of average that we get is the mode. It just always makes me think of ice cream, a la mode. The number, the mode is the number that appears most in the data set. i.e., it has the largest frequency. I'm using that terminology because that's some of the terminology that we use when we're talking about statistics. So frequency, not like in a radio tower frequency, but frequent meaning often the amount that it happens. So the largest frequency, the number of times it appears in the data set. I.e., yeah, which I think is Latin for in a priori or something like that. It means that is essentially, or written another way, it's the largest frequency. Now, as a small note about this, if there are two data values that have the same largest frequency, we call the set bimodal.
What if it doesn't, what if in a set there isn't?
If there's no repeats, excellent question. So this is the next thing. If there are more than that, there is no mode. So if there is no repeats, then the largest frequency is 1, and every number, every data value has the same largest frequency. And so there's no mode because every number has the same frequency. So excellent question. Yeah. And that would be the same thing if there were three separate data values that had the same number frequency, then there would be no mode. So if it was like whatever your data set is, but there's a 333, a 444, and a 555, then there's no mode. I guess you could technically call it like trimodal if you really wanted to, but it's usually just either the mode or the bimodal sets. Now, the mode, in my opinion, is probably one of the least useful averages, but it is useful to look for tendencies of things. So, for example, if I was given a Scantron test and I saw that like 70% of my students were getting a 44 or a 77, that would be something to tell me, okay, something's going on here, something weird is happening. And I would look at further analysis, and probably what was happening is that I asked like 13 questions that were way too hard. And so only the best students, the students who understood, not best students, that's not the right terminology. That's an insult. Only the students who understood the material the most would have gotten those problems. Otherwise, everyone would just fall short. As a teacher, you start to notice that. So I've given exams before where like I don't get any 80s. I don't get anybody in the, like when I first started out, I didn't get any students in the 80 range. And that was an indication to me that I was not like the questions were A level, like they were either A level or average levels. So C questions or A questions. And there were no like B level questions. So that's one way that I use it in my daily life. So mode is really just an interesting one. It's like it's one that like you want to look at and you're like, oh, that's strange that there was this constant thing. I was actually just watching if you haven't seen, if you're interested in Pokemon, there's this really cool YouTube video, this guy who taught AI to play Pokemon, giving it certain parameters. And so he was looking at these things and he noticed a commonality, like this common thing that happened, i.e. a large frequency of his it's called of his attempts with the AI happened in the same exact way. And so it caused him to look further. It's very, very fascinating video. I highly recommend.
So he's trying to teach how to play Pokemon with AI.
Yes. So he gives it on a reward system. So if it levels the Pokemon, it gets points. And so it wants to do that. And so what ends up happening is, so that was the only parameter at first, is if you made your Pokemon get levels, you would it would be a positive reinforcement and keep doing it. However, one time it accidentally got into a Poke Center and put one of the Pokemon into the data bank, and it lost that Pokemon, so it got a negative value. And so it now avoided the Pokemon Center at all costs. Because despite that being the most important thing when you're playing Pokemon, not that I would ever know because I've never played, it would now avoid it because when it did that one thing, it was traumatized. So very fascinating. And the point being is he found that out by looking at a lot of these entries of his AI, I forget the word for it, but like a trial of it, the runs of the program ended up having the same kind of issue. And so that would be a situation where you'd be using the mode. So now that we know all three of them, the mean, median, and the mode, we will do some examples. Example, find the mean, median, and mode of the following data sets. And round to the nearest 10th. So part A will be the data set. I'll let you finish writing that problem so we can follow along and write these ones. Otherwise, it's hard to ideally, I want you to just hear me and write it out without having to look back up, and because that's an easy way to make the mistake when you're writing your notes. So 10, 33, 50, 50, 76, 81, 50, and 11. Part B is 5, 5, 5, 5. Could just keep going on forever, right? No, 5, 5, 5, 5, 5. So 4 5s, and then 11, 12, 7, 15, and 13. As a cool little side thing, if you do want to, Excel can do this for you. It's very, very cool. You can plug in all your data values, and then in a new cell, right, equals, and you can say average, and then highlight all your cells and press enter, and it'll give you the mean. So it uses average to mean mean, and then you can also write equals median, highlight all your data values, and it'll immediately pop it out. And then I believe there's also a mode function. You can say equals mode and highlight all your data values, and it will give you the number. If there is no mode, it will probably say undefined. It'll give you a problem. So for part A, and so I know I didn't arrange this from smallest to largest, and I really want to. I want to do that, but the problem is some of the problems in the homework and stuff do require this of you. So I want to just have us go through the motions. So first rearrange, reorder first. So reordering it 10, then 11, then 33, then 50, then 50, then 50 again, then 76, then 81. I highly recommend personally, just as a little tip, to count the number of numbers that you have when you reorder it and make sure it's the same number of numbers. Because it's very easy, especially imagine you're doing this on your computer, right? You're looking back up to your computer screen, then down at your paper, then back up, then back down, then back up, then back down. There's always room for error. So it's best to double check your work. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Good. Or you can also just highlight them or like underline them when you've actually taken care of them and move on. Either way is fine. So the mean, just take the numbers and add them together. 10 plus 11 plus 33 plus 50 plus 50 plus 50 plus 76 plus 81, and divide that by 1, 2, 3, 4, 5, 6, 7, 8. 8 entries. And if you do that, you'll get 45.125, but I said to round to the nearest 10th, so 45.1. That's the mean. Any questions? Median, then? So there's 8 values divided by 2 gives us 4, which implies, so when you get an even number, when you get a whole number when you divide, you take that number and the next number in the next that entry and the next entry, and that will give you your mean. So 4th and 5th entry give the mean, give the median. So 1, 2, 3, 4, and 5. And once again, this is a small enough set that you can do it just by process of elimination, bringing it inwards and dividing and conquering. But it's better, in my opinion, to learn this trick, especially when we learn about frequency tables. So that means, so the median will equal 50 plus 50 divided by 2, which is just 50. If the number is the same number, the average of the two numbers will be the number itself. So, but either way. And then mode. Where did it do that? Okay, so I'm not sure why. Let's try that again. Started sharing. Yeah, I did start sharing. Okay, weird. It's the second time this happened. I'm guessing it's just this room has bad internet, and so it just got disconnected for a second. So for the mode, that's going to be looking at the largest number, which is 50 in this case. Because there were 3 50s and every other number only had a frequency of 1. It's just more repeated.
Shows up the most.
Yeah.
Shows up what we choose.
Yes, that's how we choose the mode. It's the number that has the most frequency, the most times it appears. Okay. So with the second example, 5 would be the mode because that's the number that appears the most. So part B is to reorder first. So we have, I don't have it in front of me. So 5, smallest number, so 5, 5, 5, 5, and then 7, and then 11, then 12, and 13, and then 15. Mean is just adding up the average, so we'll add those up. So 5 plus 5 plus 5 plus 5 plus 7 plus 11 plus 12 plus 13 plus 15, all divided by how many numbers? There are 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 entries. So we're going to divide by 9. And that ends up being 78 over 9. Yeah, 789. And that is 8.666 repeating. So approximately 8.7 for our mean. Median. So 9 divided by 2, because there's 9 entries, divide by 2, you get 4.5. So that means that the 5th entry is the median. So 1, 2, 1, 2, 3, 4, 5. But if you get a number 0.5, once again, if you divide your total number of data entries and divide by 2, if you get a number 0.5, 4.5, then the next number 5 is going to be the data value. If you get 7.5, the 8th data entry is going to be the median. And then the mode, as we said before, the mode is equal to 5 with a frequency of 4. Every other number has a frequency of 1. Mode had a frequency of 5 had a frequency of 4. Any questions on that? As a reminder, so if you get 2 numbers that have the same frequency, so if it had been 5, 5, 5, 5, 7, 7, 7, 7, there'd be 2 numbers with the frequency of 4, so it will be bimodal with the 2 modes being 5 and 7. Anything else, like any more than that, any more numbers with a frequency of 4, and then it would be no mode. All right, now let's do an example of such a thing. Example. Phil scored an 87, an 88, and a 92 on his first 3 exams. What score does Phil need on the 4th exam to have an average of 90? This is a very, very apt thing to go on. Now, granted, I know that Canvas now has that what if feature. You can just like plug in the numbers and see what happens. But this is a way you can do that without. Say what?
That's what that's.
At least that's what I've seen most students use it for, is to just plug in numbers and see like, what do I need to get on the final exam to bump my grade up to a B or bump my grade up to an A or whatever. Very, very useful. Super cool.
So we can take it off, so I can actually see the number of you.
Gotcha. I haven't had the luck. So when I was in school back in my day, we didn't have Canvas. We had, we didn't really even have a learning center. I just had to ask. But so I had to do this. This was my way of figuring it out. And even then we were graded, most courses were graded on a curve. So you just had to hope that you were right based on the standard deviation, which was always fun to calculate. So but it's a very, very useful thing. So I got sidetracked in my statement. I haven't actually been able to see that feature from a student's perspective. I'm hoping at one point to take a course here, since it's or UNLV, one of the two. I want to take some cooking courses. I think that'd be fun. And then also something on carpentry. I think that'd be a very fun skill to learn. Very, very useful. And ChatGPT is replacing everything at this point, so might as well be able to do something with my hands. So this question here: what score does Phil need on the fourth exam? That is telling you that that is our unknown. So let's define it. Let's say let X equal the score on the fourth exam. I want my average, and when they say that, they usually mean mean average. Did I write that in the problem?
No.
Okay. To have a mean average. Sorry about that. Usually they will specify. And I would say 9 times out of 10, if they say average, they mean the mean. Whenever you see like, and that's true in general across like our culture. If someone says the average, they usually mean the mean average. And it's just a situation of us being lazy with our terminology. So we want our mean average to be 90. That means if I add up 88, 87, and 92 and X and divide that by 4, because there's four data values, that needs to be equal to 90. So do I have anything that I want to write? We want the mean to equal 90, which means we have 87 plus 88 plus 92 plus X divided by 4 is equal to 90. And we can solve this in a number of ways, but we're trying to solve for X. And so there's several things we could do. I'd like to simplify the numerator first, just to combine all those numbers together, or those constants. So I get 267, if you add them together, right? 87 plus 88 plus 92. Yeah, 267 plus X, all divided by 4 is equal to 90. And from here, we could cross multiply. Do you get a different number?
But you plus X on the calculator.
So we don't know what X is yet, so we can't plug it in. So I'm just simplifying the 87 plus the 88 plus the 92.
You just do 267 divided by 4, right?
We could do that, and then you'd have to, but you also have to divide X by 4. So a better way to do it. Yes. So what I would recommend is to multiply both sides by 4. Now, granted, you could also cross multiply because you can rewrite 90 as 90 over 1, but it's going to actually end up doing the same thing. That cancels it on the left. That multiplication by 4 cancels the 4 into the denominator on the left. Let's be particular about our verbiage. And we get 267 plus X is equal to 360. And now we've got a linear equation that we've seen before. We got to solve for X, so we need to get rid of that 267. Subtract 267 from both sides. And you get that X is equal to 93. So as long as I score 93 on the exam, I'll get an A minus. That's all I need. Now, this is a bonus question. Unless there's any questions on this one. I had to solve for X, so I got rid of that dividing by 4. That's like the furthest thing out from me right now. So I'll divide by 4, and then I'll take care of that 267. Those are my like semi-acquaintances. And then I get X by itself. But bonus question, so we're going to write this in all caps just to symbolize that this is going to be a fun question. What would he need to get a mean of 97? So he's hoping for, like, apparently his teacher has it set that a 97 and above is an A plus. Anything below, like anything between a 97 and a 92 is an A, and then anything below that is an A minus. So what do we do? And this is a very, very common thing. This is what I would do. So it's the same situation, right? We still have 87 plus 88 plus 92 plus X divided by 4 equals 97 now instead of 90. And once again, we still get 267 plus X divided by 4 equals 97. And so the only thing that's changed here is we're just multiplying 97 by 4 instead of 90 by 4. So we'll multiply both sides by 4 to cancel the 4s on the left. You get 267 plus X is equal to 97 times 4, 388. And once again, subtract 267 from both sides. And you get that X is equal to 121, which is not feasible. I mean, maybe this course does have extra credit, but I doubt it's 20 points worth of extra credit. So unless the exam, unless the fourth exam has extra credit, an average of 97 is not possible. Any questions on that? So, just as a observation, so that'll happen sometimes if you saw, like, so this is what I do actually several times a year, because a student will ask me, what do I need to get on the exam to get an A in the course? And I'll be like, okay, let me go through and calculate. And then I see that the score that they need on the final is above 100%. I'm like, there's no extra credit on the final exam, so that score is not feasible.
You really asked for that?
Yeah. I mean, like, it's a, like, not many students know about the whole what if feature. And so they just want to know. And the other thing that's kind of difficult here, especially with my course, is that things are weighted differently. This is really, really nice and neat if things are weighted the same, like all the points of the are equal. But for my course, the like for my calculus course, my exams are worth 20% each. And the final exam is worth and the quiz is worth 10. So even though like 10 quizzes doesn't amount to the same amount as one exam, despite it being 10 points for a quiz, 100 points for an exam. So I've just kind of tweaked the number so it's better for me, and easier for me to calculate. So that's a situation that requires a little more nuance, but this is enough for us. Another example, and this one I'm only purely doing because it's a question on your homework. The mean score on a set of 25 exams was 79.2. What is the sum of all the exam scores? Like this, I just don't like this question. I'm sure there's a different way you could ask this, a different scenario that you could create where knowing the sum of all the exam scores or the sum of the scores would be useful. But for this, I mean, what is that going to tell me? But just because it's a problem on your homework, I wanted to go over it. So the mean score. So solution, the main thing here is to understand, I guess, the critical thinking behind it is that what does the mean mean? What does the mean average mean? So the exam mean score is equal to the sum of all 25 exams divided by 25. That's how we would find the average. We would add up all the exams, divide by 25, and that would give us the mean. So the exam median score was a 79.2. And let's just call this X so we can write a nice equation for it. Call this X. So we get 79.2 is equal to X over 25. And we'll rewrite this as 79 over 1 so we can cross multiply and get that X is equal to 79.2 times 25, which ends up being 1980. So not really useful, right? So my students scored on a out of the 2,500 points total on my exams. Cumulatively, they added up to 1980. Useful, not really, but critical thinking of understanding what the mean does, somewhat useful. All right. That was it. All right. Now I want to talk about the reason why the mean is something that's greatly skewed. So example, a new startup company called Jamazon.com has 5 employees. 4 of the employees make 40,000 a year. And the manager makes $200,000 a year. Literally 5 times as much. That was actually pretty normal back in like the 1970s, maybe a little bit before that. And then a good old man named Ronald Reagan came in. Much like Miley Cyrus, he came in with a wrecking ball. Always fun, like seeing how many things have changed purely because of Ronald Reagan's presidency. Interesting dude. So a recent ad put out by the company, so you know it's not biased at all, claims that the average salary is $72,000. Which, if you do calculate the mean average, if you do calculate this 200,000 plus 400,000, or sorry, 200,000 plus 40,000 plus 40,000 plus 40,000 plus 40,000, and divide that by 5, you will get $72,000. So my question is, why is this disingenuous? Me too. Disingenuous. I hope I spelled it right. I'm not an English major. But really, like, and we've kind of already talked about it. So
Like you're just saying employees make 40.
Yeah. Yeah, the 4 of them that work like under the manager, they're making 40,000. What?
Like for FOR, not FOUR.
Oopsies.
Very.
Thank you. Oopsies. 4 employees make $40,000 a year, and the manager makes 200,000. So the reason why I would say this is they're using the mean as the average. Yeah. Not the mean, not not the median, not the mode. But either one of them would be 40,000, which is far more representing of what the average employee there makes. So they're using the mean as the average, which is greatly swayed by outliers, such as the manager's $200,000 salary. The median would be a far better representation of average salary. That brings up a good point for you guys as well. So in any of your courses, not just mine, there is a way, if I remember correctly, there's a way to look at the average score on an assignment. So like you can look, like when I enter scores in for the exam for you guys, you can like click on the exam and it'll tell you the average. That's the mean average. And so the problem there is that if a student doesn't take it or like has dropped the course, but I still have to enter in the data for it, that answers a 0, which is greatly skewed to the left, to smaller. Like the average student gets like a 70, 65, 88, 97, whatever. And that 0, I mean, they got a 0. Very, very few students in my classes have ever gotten 0s on an exam on purpose. So when I enter in those 0s for people who have either dropped the course or just stopped coming to the course in general, that has to be entered. And so when they look at the mean average, they're like, oh my God, Phil's average on his exam was a 62%. That's way too hard. It's like actually the average, if you look at the mean, if I got rid of the 0s, the average was like a 75. So, which is far more fitting. So that's the situation. Now, jump this up to maybe like what this problem is actually meant to talk about, which is a certain other company where the owner has over $1 trillion, right? What is Jeffrey Bezos worth? Over $1 trillion? And the average Amazon employee makes how much? I don't know, but that trillion is a very, very large number. And if you included his salary, it would greatly show, like it would show that the average Amazon employee was like in the six figures at least. So very, very good, like very apt thing to be looking out for. So whenever you see something online or a headline that says the average or whatever, always question saying, what average are you talking about? Because if you're using the wrong average, you can skew data however you want. There's that line from what's his name? The famous writer. God, I think he wrote what is his name? Mark Twain. Like he's quoted with saying, there are lies, damn lies, and then there's statistics. Because statistics really can be, especially since there's 3 different types of averages, you can really try and fit whatever narrative you want just by using the right average and hoping that the population is not smart enough to know the difference. So, okay, any questions on that? The next thing, so now we're going to be talking about what we call frequency tables. So definition, a frequency table is a data table used to represent large data sets. By breaking up the values based on the frequency at which they occur. So this is particularly useful if there's not really any like, so if you have decimal numbers, then there's no real use to doing a frequency table because like there's very rarely going to be people having the same thing. But if you're talking about like an exam score that only ends in whole numbers and it's for like a whole college or whatever, then all the numbers are from 1 to 100, right? There's people who are getting 1s, 2s, 3s, 4s, 5s, and you've got at CSN, we've got 15,000 students, I think 7,000 students on campus at any given time, on all our campuses, that is. So like trying to find the average score of all those students, I don't want to write out 7,000 numbers, so I'll write a frequency table. So I'll show you an example of what a frequency table looks like versus its corresponding data set. So a frequency table right here. Versus the corresponding data set. So the frequency table is a 2-column chart. So it says data and frequency. So the data is 15, 31, 50, and 86 with frequencies 2, 1, 4, and 2. Now, this is a situation where I wouldn't bother using a frequency table because there's only going to be a total of 9 values. But what if this was a lot more? What if that was a frequency of 15 for the 31 instead of 1? Then that would be a situation where I definitely want to write out the frequency table. So the corresponding data set would be 15, 15, because there's a frequency of 2 with the 15s. There's only a frequency of 1, so there's 131. Then there's 4 50s and 2 86s. So that's how a frequency table breaks things down. And it allows us to represent data in a much more compact form, which, if you know statisticians, they love to write things as concise as possible. Just like mathematicians, we do like to try and make sure that we write as little as possible. Right? Instead of writing 1x, we just write x. The same idea. What time is it? We got 5 minutes. So we'll get enough time to write down the problem statement, but that'll be it. So example. The following frequency table displays the number of students in classes at an elementary school. Find the mean, find the median, mean, and mode. And so here's the table, and that's where we'll leave it for today. So students, I'm gonna make this box larger. I didn't make this large enough for me. That'll be better. Students and then frequency. So classes with 14 students, there are 9 of them. 17 students, there are 7 of them. 21 students, there are 8 classes with 21 students. 26 students. And 28 students, there's 2 of them. So overall, it's a pretty good elementary school. They've got most of their classes have a class size of under 20 or under 21, I guess. Actually, speaking of which, this is actually something funny. When I first got hired here, I was looking at a flyer that was being passed around, and I'm not bashing CSN at all, but it said the average class size was 19. And I was shocked because I looked at my rosters of the classes I was teaching, and all of them were over 31. And I was like, where are they getting this number? And it's because a lot of other courses in our college have like small class sizes. And so if you take the mean average, it's a lot less. Whereas we are the outliers, but there's a lot more outliers on the left-hand side that have less students. So it was an interesting little factoid about abusing the word average. I think that'd be a nice way to fix our problem, is to just make sure we say mean average, median average, or mode average when we're talking about averages. But either way, I digress. That'll be it for today. I hope you guys have a great rest of your week. Please take that exam as soon as you can so you can get time to look over it and come back to me with questions if you have them. Otherwise, you guys have a great rest of your weekend. Good luck on the exam, and I'll see you on Monday. No, this is section 3. This is chapter 3, so this won't be on there.
If it's on the
Let me